Started off with first generation cellular, which was analog, and then everyone wanted to move to digital.
TDMA and GSM were the original digital telephony, cellular telephony technologies that were in use.
This very strong academic push for CDMA, that was the environment that we found ourselves in when we were trying to decide between using CDMA and GSM.
Just taking the step from, theoretical proof of concept to real commercial, where you put millions of users on the network and make it work as predicted. That's what took a lot of the effort from the OEMs that worked on the technology at the time.
The folks at these companies really made it happen. They were the quiet heroes in all of this.
When I joined wireless in 1996, I came in, Bill, you were the boss of hardware at the time, and then you went on to better things, and I took over your mess. So I arrived in 96.
I started working on CDMA with Qualcomm back when Irwin, I think he was in a partitioned office in a small little office park still in La Jolla. I was the first developer of this channel unit for CDMA. So that's going way back. I don't know if that thing actually commercially worked really well, but there was a lot of evolutions to that.
I joined Bell Labs in '84 in the wireless group, and we were starting to work on digital cellular stuff then. And we actually built a whole demonstration with an FDMA channel initially. And then in '89, I guess a request went into management up in Murray Hill and said, hey, this company Qualcomm has some demo system in San Diego. They want someone to go see that. And it worked its way down the line and eventually got to me and MTS in Whippany in '89. So I was actually the first AT&T Bell Labs person, I like to say, that stepped on Qualcomm soil.
Around 89 or 90, so this is around the time that you were just referring to, Jim Brewington came to the research group and he just asked us, there was a lot of argument in those days about what has greater capacity and everything. So from a sort of a theoretical perspective, everybody was looking for how do we get the most capacity in the air interface when we were making this transition from analog to digital. And he didn't care about that at all. The question Brewington asked us, he said, this thing that Qualcomm has, can we actually make it work? And can we make it work at scale? Is there any reason why it won't work? And so his interest was really, it was such an exotic technology compared to what we were used to really looking at in radio, that for business reasons, his interest was in if we could do something different. And this was really different.
I started in 1989, and I wasn't doing CDMA at that time. I was at the finishing my master's at the Center for Quantum Field Theory at University of Alberta. Then I read this one little paper, and I can't remember, I think it was in Spectrum, about this communication and noise. And I go, how the heck is that going to work? How does that work? So I started looking into it, and then I decided, okay, I'll just go do my PhD on that. So I did my PhD on CDMA, and I was a MUD guy, multi-user detection guy, and presented a number of papers. And I remember going to conferences where, there were people from Qualcomm and people from Motorola. I even remember one conference where after one presentation, I can see the guys from, I think it was Motorola, who was madly typing on his laptop, changing his presentation based upon what the Qualcomm guy said. So that was the big debate about what type of modulation we should use for switching, as you say, from analog to digital. I had a chance to join Qualcomm or Bell Labs. In '95, I met someone you all know, Ronaldo Venezuela. And I think at that time, Bell Labs was trying to switch to being Lucid. And Ronaldo said to me, don't come, because we don't know how to make money. So it turns out I went to Qualcomm.
It was literally this little company in San Diego, in La Jolla, that was trying to move an entire industry, right? And back then it was Nynex, Ameritech, Pactel, all of the players. These are the stodgy RBOC operators, right? And this little company was trying to convince them to make this super important decision to shift technologies. Just the fact the entire nationwide network had to be synchronized within, 1 to 3 microseconds.
I see, like 1 to 10, 1 to 3 microseconds.
I mean, it's like, really? How's that going to work?
TDMA was just understood. But in CDMA, it all hinged on whether we could do power control accurately enough. Because if you didn't get the power control working, then you just didn't get the capacity. The whole purpose for making this transition from amps to the digital world was to build capacity.
Right? No one was thinking about data rates then. They were thinking about capacity. And we said, well, we're going to use CDMA, right? But CDMA itself is just a multiple access method. It's not necessarily any better on paper than FDMA or TDMA, but what came along with it was these other techniques, right? The like you said, power control, softer handoff, so you can keep the power down and deal with overlap.
Actually, Joe, I have some pictures, but I actually found this too.
Wow, you have a lot of memorabilia there.
I do. I mean, so that one there is a channel unit. It's hard to see, but it's got 20 little chips there.
Yeah.
Each one of those is a channel. It's one channel of capacity, right? And we will have like how many of these on the base station? I forgot, 5 of these or something. I forgot the number.
Yeah.
And then you had this thing here, which was a processor from Intel,
the 960. Yes.
960, which they decide to,
discontinue.
And it gave us the story. Hey, I'm sorry, you guys gonna have to buy something else, right? And we built this thing called the radio control unit. You can see it there. Right? That's the big monster, the i960. And when you look at these boards, it's like these things were complex. How the heck we build those things? We had no simulation tools, nothing, right? So they decided they want to get rid of this processor. So now we're scrambling. There's thousands and thousands of boards we're putting out there, and now we got to go to another processor and redo all the code. It was like, I don't remember the solution to that. You remember, we worked to Motorola or something, I don't remember. But anyway, the point of the story is that not only we face challenges on the new technology, right? We face challenges making the hardware. We face challenge getting this hardware to operate on a global, on a nationwide network. The software, the billing, all that stuff coming together. We never built anything like that at the time.
Your point is a good one, because back in the day, it was a 5 nines culture. So you didn't just turn something on and expect it to hiccup and finish or fix it as you go. It was like, that's going to work, and it's going to be 5 nines, right?
Yeah, you tested the 5.9 before you put it out there. You test it and you test it.
Right, exactly. But we had redundancies levels built in because we worked to 5 nines. Even our base stations, we were hell-bent on making that 5 nines, right?
And we had some great engineers, right? I mean, there were some of the hardware guys that I had on the team were just fantastic.
Guys, I'm going to tell you, like, I'm looking at the dream team right here. You guys were amazing. And, there's a lot of other people that I'd like to include in that category. I'm going to shout out John Marione. God bless, bless him. Like, his leadership in the whole thing, that was huge. Mary Chan, all of these people, like, just made it all come together. Right. And, honestly, I think it was the kind of the DNA and the culture we had married up with Qualcomm, and Qualcomm was just fantastically managed from the top down. I think that's the only way it worked. I really do. Like, that's it.